All right, so we're continuing on in 12.1 here. We had just finished example 3. If you haven't gotten that far, please go back because we're going to build from there. So just a quick reminder here, we're hypothesis testing for the chi-squared goodness of fit test. And so we talked about in the last video the null and alternative hypothesis and the test statistic. And we use the table to determine that. And now we need to find the p-value. And so there are two ways to find the p-value. You can use the chi-squared table or you can use Excel. And we will use Excel, but I'll just briefly talk about the table if you want to kind of use it. It is in your textbook. And you find the degrees of freedom here. So let's go back here. Our degrees of freedom is k minus 1. And we need our degrees of freedom anyway, but we would just kind of go across and with our alpha, make sense with the degrees of freedom here and find our test statistic. And I'll show you in our next example. But for the most part, we're going to be using Excel here. So we're only considering K trials where the expected value is 5 or more. So we're going to see an example of that later. All right, so let's look at example 4 now. So this is a continuation from example 3. So again, go back to the previous video. We are up to this point. We calculated this test statistic. We did the null and alternative all in the last video. So now we're going to build here. So now we are going to answer this question. At the 5% significance level, we want to determine whether there has been any change in the population proportions calculated 1 year ago. So in this problem here, we have our chi-squared, but we need to determine our p-value to compare against alpha. We know our alpha is 0.05, but we need our p-value. So to calculate our p-value, we are going to use the formula chi-squared dot dist RT, and then we're going to put in our test statistic and our degrees of freedom. Okay, so in this case here, our degrees of freedom, K. Our K is we've got 1, 2, 3, 4. 1, 2, 3, 4, and each expected value is over 5, so we're good. So our degrees of freedom is going to be 3, and our test statistic is 6.52. So using Excel, we're going to find the p-value, which is going to be equal to chi-squared dist RT. And our x is 6.52, and our degrees of freedom is 3. And we get 0.089, 0.0888. So our p-value is 0.0889. So how does our p-value compare to our alpha? Our p-value, 0 is the same, 5, the 8 is bigger. So our p-value is greater. So we do not reject the null. Remember, p is low, null must go. So our p is greater, so we keep the null. So we're keeping this. So what that means is that we expect that they're going to stay the same. So we cannot conclude that there will be any change in the proportion. So even though they change their menu, we cannot conclude that that is going to change the ratings based on this data. We cannot conclude the population proportion will differ from a year ago. All right, so that is how we would do that. Now, let's take a look here at the table. So how we would use this table is we are looking here at our degrees of freedom is 3, so we're in this row here, and we're looking for the our test statistic, which is 6.52. So 6.52 is between these two values. So we know that our p-value here would be between 0.10 and 0.05, which it is, but we can get an exact value using using Excel. So we're just going to use Excel, but that's how you use the table in case you wanted to know. And that's it written out for you if you want to take a moment to just recap here. All right, let's do an example from top to bottom. So this lists the market shares of 5 firms that manufacture a particular product. They wonder whether the shares have changed since 2010, and they survey 200 customers. So the last column shows the number of customers who recently purchased the product. So let's find our alternative and our null, because we need those for our hypothesis testing. So we use the original observed values. So each of these is different. So we're going to use that P1 is equal to 0.4, P2 is equal to 0.32, P3, 0.24, P4, 0.02, and P5, 0.02. And our null is that the proportions are not hypothesized values, right? They're different. Okay, so that's done. B, calculate the value of the test statistic. So we're going to go into Excel. And we are going to do, we can, if you want to start it over here, we can. O minus E squared, O minus E squared divided by E. And remember that the sum of that is going to be our test statistic, the sum of that column here. All right, so our observed value. All right, so what did we see happen? We saw that there were 70, right? We saw that there were 60 and 54 and 10 and 6. Remember that these values are our frequencies. They're not probabilities. Now, for our expected, we're going to take our n, which is 200, and we're going to multiply it by the hypothesized proportion here. So we've got times that, n times 0.32, n times 0.24, n times 0.02, and n times 0.02. And then we just want to double check here that all of these are good, that they're all greater than 5. And we see here that these two are not greater than 5. Okay? These are 4. So it's not like we just stop and quit here. It's just that we can actually say, instead of comparing firm 4 and 5 separately, let's compare them together. So let's combine these two columns so that we can actually do this with all the others. So instead of 0.02 and 0.02, we're just going to make this 0.04. And instead of 10 and 6, we're going to make this 16. And we're just going to call this, it can be called firm 4 and 5. But then the only thing that's going to change is that is going to change our alternative and null, because we actually need this to be 0.04. Okay? And again, we know when we interpret these values on the back end that we're talking about, so this is firm 1, firm 2, firm 3, and this is firm 4 and 5. And so we're just going to say, okay, that's 16 now. And so we know it's going to be doubled, but we can do 200 times 0.04. And there we go. And now we were good. We don't need to worry about that anymore. And then we'll just continue on. So this is going to be the observed minus the expected. Drag it down. This is going to be this value squared. Drag it down. Oops. And then this is going to be this value divided by this. Drag it down. And so here, this is the sum of this column. And so our test statistic is, our chi-squared test statistic is equal to 10.25. So now, using an alpha of 0.05, determine if the market shares have changed. So we need to find our p-values. So let's find our degrees of freedom. So our degrees of freedom is equal to k minus 1. Now remember, originally we had 5 categories, but we changed it to 4. So our degrees of freedom is actually going to be 3. So our p-value is going to be chi-squared dot dist and 10.25 and 3. So our p-value is so our p is equal to 0.0166. And how does that compare to an alpha of 0.05? So 0, 0 are the same, 1, 5. P is low. P is smaller than alpha. The p is low. The null must go. So we're going to reject the null. And so what we can conclude is that the proportions are not their hypothesized values, that that something did change. So we can say that the market shares have changed since 2010. All right, and there it is written out for you. And when we come back, we'll do one more example altogether and then a couple of U-tries.